Okay, in this lecture, let us look at how the program execution takes place. So, you write a program using any high level programming language. Alright, let's say you write it in C or Java or any other programming language. Okay, so what you get is, first you have a file and say it's a C file, so you call it first.c. Okay, so this consists of codes and you have saved it with first.c. So this is your source code. This is your source code. Alright, so this program, when you create it and you save it, it is stored in the auxiliary memory, that is your hard disk. So it is stored in auxiliary memory. Now what is the next step that you do? After compiling the program, now you have to run it. So when you compile a program, so you compile, you use some compiler and then you compile your .c program, okay, you get what is known as an executable. You get an executable file. So this executable file also is stored in your auxiliary memory. Alright, so this executable file may contain instructions in machine language. Okay, so it may contain some machine language code. Okay, so this machine language code can be executed directly on the computer. So now the next step is you want to run the program or you want to execute the program. So when you want to execute the program, the exe file or the executable file has to be loaded into main memory. It has to be loaded into main memory. So you have to load this program into main memory. This is first thing what is done. So now this executable program consists of, it has instructions, and it has data. So when you declare a variable or a constant, it is the data, and any other executable instruction, this falls under instruction. So in the executable file, when you load it into main memory, all the instructions are kept together and the data is kept together. So the instructions are stored in a place known as the code segment, or this program itself, the set of instructions, this is known as the code segment, and the data, that is the variables and constants that you have, this is stored in the data segment. This is stored in the data segment. So you have a code segment which will consist of the instructions, and you have a data segment which will consist of the data. So when this is stored in main memory, then the code segment is kept together and the data segment is kept together. Alright. So with this knowledge, now let us go and let us look at this. So here you can see this, what you see here, this is your main memory. This is the main memory. Okay, so now as you can see out here, we have this section which is it says program, so it contains the code segment. This is the code segment, and then you have another block here which says data, so this is nothing but the data segment. So you are executing a program, the program has been loaded into memory, the instructions are kept together in the code segment, and the data is kept together in the data segment. Now, in addition to the code segment and the data segment, you have a stack. You need a stack to execute. So you can see this is the stack, and you understand what we mean by a stack. Okay, it always grows upward. Okay, and you can only add and remove from the top. So this is your main memory. Now you can see these numbers that are written out here. These are the addresses of the memory location. So we assume that every memory location has an address which is represented by these numbers. So for example, this location is represented by 4001. This location is represented by 4002, and so on. So here we have the program segment, the data segment, and the stack. Now if you look at this side, we have some special purpose registers out here. These are known as the special purpose registers we had been talking about earlier. So PC here stands for the program counter. So the program counter, as you can see, if I just remove these markings, so the program counter, you can see that it is pointing to some area in the code segment, that is the program part of it. Similarly, you can see the stack pointer, SP is the stack pointer, and it is pointing to the top of the stack, to the element at the stack. Then you have AR, this is known as the address register. DR is known as the data register. Okay, so like this, these are some special purpose registers. So the program counter, as you can see, is pointing to one of the instructions in the program segment or in the data segment. So the program counter holds the address of the instruction that is to be executed next. So at any time I want to know which is the next instruction to be executed, I will only have to look at the value in the program counter. So that will give me the address. Similarly, if I want to know whatever is at the top of the stack, where is the top of the stack, I will have to look at the stack pointer. Now this address register and the data register, they have a special purpose. Address register, as you can see, it is pointing to the data segment. So the address register holds the address of the operand. So current address of the operand it holds. So if the current address of the operand for the instruction that is being executed, the operand is there wherever this AR, whatever address this AR holds. So if AR holds the address, say 2004, that means in location 2004, this is where our operand is. Okay, and then the data register, now what it holds? It holds the value which is there the data register holds the value which is there inside this location. So address register holds the address. Suppose this location holds the value 20. So the data register will hold the value 20. So address register holds the address of the operand. Data register holds the operand. Okay, so once you know where to look at, where to find the next address, next operand, you would get it from the address register, fetch it from here and put it in the data register. And the ALU now can access the data register and take it. So remember, this part is your memory and this part is your CPU. So you have the registers out here.